So we're going to continue with some of the history of the discovery of the atom and the advancements of the model of the atoms to bring us up to present day. So we're now in 1913, and a Danish physicist, Niels Bohr, discovered the orbits of electrons. And what he discovered is that they are located at fixed distances from the nucleus. So previously they had been kind of random movement, but what he discovered is that these orbits are fixed distance. So there's 1 ring, 2, and 3, and all the way up to 7. And these are set distances away from the nucleus. It's very orderly. And so we call these energy levels. Energy levels are areas located at fixed distances from the nucleus of an atom where the electrons can orbit. It's kind of like rings of a ladder. You can stand on the rung, but not in between them. Same with an electron. Electron can occupy an energy level, but it cannot be in between them. So the lowest energy level is located closest to the nucleus, and moving further away from the nucleus will increase or have higher energy levels. Electrons can jump from one energy level to another. So if it starts off in this first energy level, it could jump up to the third energy level. And so that happens when it absorbs some energy. If it stops absorbing energy, so absorbing energy allows it to jump up. But as soon as it stops and it starts to lose energy, it will go back down to where it was originally. If an electron moves to a lower level, it will emit energy. And oftentimes we see that energy as light. So when do we see this in real life? Chemicals in fireworks, they absorb energy and the electrons will jump to higher energy levels. And then when the electrons move back to their original energy level, they give off energy as light. And different chemicals have different arrangement of electrons, which gives them their different colors. And so that's what makes fireworks so spectacular, is it's just a different mixture of chemicals. They get that energy, and the electrons jump to higher energy levels. And as those electrons fall back down to their original energy level, it emits light. So in the 1920s, physicists discovered that electrons do not travel in a fixed path. Electrons only have a certain chance of being in any particular space. So it's actually very hard to predict a location of electron. And in order to do this, you have to use some mathematical formulas. And so, lucky for you, these mathematical formulas are insanely complicated. And so we have to use computers to solve them. And so what they found was that electrons can behave like waves as well as particles. So a wave has this up and down motion where a particle can bounce here or there. And regardless of how they behave, they're always going to be attracted to the nucleus because that nucleus has a positive charge. So since electrons can behave like waves, they can bend around the nucleus instead of falling towards it. So the electrons will only exist where the wave is stable. And this is what we call the orbital. Very similar to the energy levels. So this gives us the electron cloud model. And an electron cloud is the area surrounding a nucleus of an atom where electrons are likely to be. And so this white area here is our electron cloud. So this whole area shaded in white is where we have the highest chances of finding the electrons. And this is today's accepted model of an atom. So, talking a little bit more about orbitals. Orbitals are region of energy. Region of an energy level in an electron cloud around an atom where electrons are most likely to be located. Some regions of the electron cloud are denser than others. So if it's a denser area, that indicates there's an increased likelihood of finding the electrons there. Each orbital has a maximum of only 2 electrons. So if there's 2 electrons in that orbital, it cannot take a third. They max out at 2. And then our different energy levels in the cloud have a different number of orbitals. And so then different energy levels would then have a different maximum number of electrons. So here we have our first energy level. The first energy level has 1 potential orbital, and since each orbital can only hold 2 electrons, there would be a max of 2 electrons in that first energy level. Then if we jumped to our second energy level, a little bit higher, there can be 4 orbitals, and in each of those 4 orbitals, we can take 2 electrons, so 4 times 2 gives us 8 total electrons. The third energy level can have 9 orbitals, and each of those 9 can hold 2 electrons, so 9 times 2 gives us 18 total electrons for the third energy level. And then we have our fourth energy level, so this is even further away from the nucleus. In that energy level, there are 16 little orbitals. And those 16 can again hold 2 electrons per orbital. So 2 times 16 gives us 32 electrons. And so this is where we'll really, if you take chemistry, we really get into the details of this more. So the most stable arrangement of electrons occurs when electrons fill the orbitals at the lower energy level before the higher energy level. So in this first energy level, right here, closest to the nucleus, we can have up to 2 electrons, which is what it's showing us. In the second energy level, we could have up to 8 electrons. Again, each of those are placed. So these electrons are going to fill the energy level before being placed into the next one. So notice how both the first energy level and the second energy level are full. So that's why these 2 electrons can be placed in the third energy level.